tracer. And the sine tracer is going to trace out the function of, of the sine of x. We all know what the graph of the sine of x looks like, but the two questions that we want to get out of this lesson are, what is on the x-axis and what is on the y-axis? Okay, so the x-axis is actually measured in radians, and the y-axis measures the height of the triangle formed by theta in a unit circle with a hypotenuse of 1. Recall that the sine is equal to the opposite over the hypotenuse. So if the hypotenuse is 1, then we just have the length of this side. So what we're going to be doing is tracing a free point going around the circle, and we're going to ask ourselves for each coordinate point, how far did the free point travel, and what is the height of the triangle at that point. So let's start by looking here at the x-axis. So if a free point has traveled all the way around the circle, it's traveled 2 pi, because we know that the radius is 1, so the circumference is going to be 2 pi over 1. So this circle is 2 pi. So your sine tracer will fit. I'm not sure if it's going to fit here, but let's hope so. Perfect. Okay, so from there is 2 pi. That's 2 pi radians. So what do I mean by 2 pi radians? A radian is a radius. So this is 1 radian. Okay? The same thing. Another way to say that is this is 1 radian. So free point traveling would be to here. That would be 1 radian. Another radian would be about there. And then this is going to be 3.1 radians. So half the way around the circle is pi, or about 3.14 radians. So no matter how big the circle is, you have gone 3.14 radiuses when you've gone halfway around the circle. Okay? There we go. So this is 2 pi radians, this is 3.14 radians. So let's do a couple more and continue to mark off in terms of radians. Pi over 6 is about half of a radian, right? 3.14 over 6, that's right here. So this measure right here is pi over 6. So when the free point has gone around the circle to pi over 6, meaning this theta here is pi over 6 radians, this theta right here, okay, is pi over 6, we can say it has gone pi over 6, the free point has traveled this far, pi over 6 radians. When we go up a little bit higher, we see this next one here, this is pi over 4 radians. So that's right here. That's pi over 4 radians. If I continue on, this would be pi over 3 radians. Continuing on, this would be pi over 2 radians. Continuing on, let's just go to this one here. Okay. This is going to be 3 pi over 2. Sorry, 3 pi over 4. And this one is 5 pi over 6. Make sense? Let's just do a couple more in the third and fourth quadrant. If I go halfway down, this way and this way, the third quadrant, we have, or over here we have 5 pi over 4. And in the fourth quadrant, we have 7 pi over 4. So, the first thing that we've done is explain, we've explained now where the measurements for the x-axis come from. The radians, or the number of radiuses that the free point has traveled around a unit circle. Next thing we're going to do is we're going to look at why does the sine function look like it does. So we're going to actually use what I'm calling a sinTracer here. If you recall, as I said, we're looking at the vertical component of the triangle that's formed by the free point and the x-axis. So when I go to pi over 6 here, okay, I form this triangle right here. Okay? This is pi over 6 radians, or 30 degrees. What we're looking at then is we're saying when it's gone 30 degrees, this is the vertical component right there. So if I put my finger right here, I can map that on to pi over 6, and I can say this is the height right there of the triangle. Now, when I go to pi over 4, we can see that the height is higher. Okay? It's up to here. So again, I'll put my finger there on pi over 4 and map this over to pi over 4, which is right there. Okay? Now when I go to pi over 3, we have this height right here. So I'm going to map that straight across, and pi over 3, this goes right there. Now at pi over 2, it's at the highest point it can be, which is here, which is at 1, or 1 full unit across. Now we start going down again, okay? This one here, 3 pi, well, actually, it looks like let's do 3 pi over 4 here. Now we've got the triangle going this way, but you can see the vertical component is right here. So at 3 pi over 4, the vertical component has come down to here. At 5 pi over 6, our triangle is here, so the vertical component is here. Now notice what happens here. The vertical component is completely gone. So at pi, you actually start seeing that this has gone back down to 0. Now let's try 5 pi over 4. The vertical component is actually now gone negative. It's this far. So I'm going to put it down here. So at 5 pi over 4, I'll put this here. It's negative. Okay? At 3 pi over 2, which is down here, the sign is all the way down at -1, down there. And at 7 pi over 4, it's starting to go back up. It's back here. And at 2 pi, we can see it's back to 0. So the sinTracer starts at 0, it goes up, then it comes back down, and then we get the negative, just connecting these dots, and there you have a sinTracer.